Hi everyone, welcome to my channel, Maths Made Easy with Terry in 10 minutes. Okay, don't forget to subscribe. If you've not subscribed, what are you waiting for? All right, so we are going to talk about solving simultaneous equation now with three unknowns. All right, so in the previous video, we talked about solving simultaneous equation with two unknowns, where we talked about the elimination method and the substitution method. All right. So what we're going to do now is that we're going to talk about how do we now solve simultaneous equations when we are having three unknowns. So please, you have to review the previous video if you're on the elimination or substitution, because we're going to use that same method, those steps in this video. All right. Now, with three unknowns, the three equations and the method of solution is just a little bit an extension of the two unknowns. All right. So the three unknowns is an extension of the two unknowns. So that means here the workings will be a little bit longer. All right, definitely, because we're having three unknowns instead of two, but it's going to be also very simple. All right, so I'm going to jump into it. Okay, so there are 6 rules or 6 steps here. All right, unlike the two unknowns where we have 7, so there are 6 rules here. So the first thing, similarly to the two unknowns, you have to arrange the 3 equations one on another. So you have to have the x on x, and you have to have the y on y, and you have to label each one. Okay, so you have to arrange, okay, the 3 equations. Okay, one on another. So we have the x on x and the y on y. Then similarly, you have to also label each of them. So it's very important to label so that it will also help the marker or the reader to understand how you solve it. Also help you as well, so you can trace back on what you're doing. So it's and label each one. Is that okay? So for instance, you can say equation 1 and equation 2. Okay, so we're going to arrange the 3 equations one on another. So you have the x on x, you have the y on y, and you have to label each one. Now, when you're done with that, the next thing you have to do is that you have to take any pairs of the equations. So it could be equation 1, it could be equation 2, but you have to do it in such a way that you have to eliminate one of the variables. Now, so you have to use any of the step 2 and step 3 in the 7 rules I talked about for the elimination method, all right? So when solving simultaneous equations, so you have to go back to the previous video. So when you go back to the previous video, the step 2 and 3, where I talked about that you take the coefficient of x from the one of the equation and multiply the previous one, and take the equation of x from equation 1 and multiply equation 2, and vice versa. All right. So now when you're done with that, you have to take any of the pairs and you have to do that multiplication. But the idea of doing this is that so that we can have one of the variables disappear. So instead of having 3, after step 2, we're going to have 2 variables. Okay. So basically what I'm saying is that you have to take any pair of equations and eliminate one of the variables by using step 2, okay, and 3. So please go back to the previous video in the 7 rules. Okay, I talked about this in the previous videos in the 7 rules of elimination method. So if you're writing notes, make sure you just go back, check your notes, what the step 2 and 3. We're going to apply it there when solving. With 2 unknowns. So I will advise you, like for this, just try and see previous videos, okay? So I'll just say see previous videos. So I've talked about this before, so I'm not gonna just beat this step a lot. So when you've done that and you've eliminated one of the variables, okay? The next thing to do is that you have to take another pair of equations. So like for instance, we have 3 variables, okay, or 3 unknowns. So you have to take another pair of the equation and you have to repeat step 2. So I'm going to pick an example and explain. So basically what you've done in step 2 with a pair of equation, you have to select another pair and also repeat the same thing. So let's say we have, so take another pair, okay? And repeat step 2. So that the same variable disappears. So that the same exact, so it's very, so it has to be the same variable that disappeared in step 2 must be the same exact variable that should disappear as well when you do step 3. Okay, so I'm going to solve an example. Okay, don't worry about it. Now, when you're done with this, so step 4 is that, so when you've done with step 1, step 2, and step 3, then we now have to use those 2 new equations. So remember, we took a pair of equations from step 2, we got a new equation. Step 3, we took another pair, we got a new equation now. So those 2 equations now we have to then solve them normally using either the elimination method or substitution method that we learned in the previous video. So that means the new 2 equations we have, we then solve them using simultaneous equation. Substitution method or elimination method as normally now because we only have 2 variables. So the essence of step 1 to 3 is that we're trying to eliminate the 3rd variable so that we can now have 2 variables to now work with as we have normally done. So then we now solve the new equations. From step 2 and solve the new equations from step 2 and 3. Okay, so solve the new equation for step 2 and 3, then we're going to solve them, okay, as normally, okay, using all the steps, so all the 7 rules. So using all the steps of the 7 rules. Of either elimination, okay, or substitution method. Okay. Substitution method of simultaneous linear equation. With 2 unknown. Okay, so then you solve them as usual. Then when you solve them, then the step now is that you have to substitute the 2 values from step 4. So that means you solve them, you've gotten x and y, all right? So when you solve them from step 4, you've gotten x and y, but there's a problem. We have 3 unknowns. So that means you have to now take those x and y, go to the original question or equation from step 1 and substitute it into any of them to give you z. Does that make sense? So remember, we're having x, y, and z. After step 4, we've gotten x and y. So then we'll now take it to the original equation to get z, all right? So that means the step 5 is that you have to substitute the two variables. So it could be x and y. Does that make sense? From step 4, okay, into any of the equation. It has to be any of the original equations, okay? From step 1 to get the third variable. All right. Now, when you're done, you've gotten the third variable now, we're done. So now we've gotten the x, we've gotten the y, we've gotten the z. So now we'll now check, okay? So you can now check if you need to. To confirm in any of the original, so any of the original equations. Is that okay? Okay, and that is the 6 rules. Okay, that's the 6 rules. The first thing, you have to arrange it. You have to take any pair. You have to take another pair of equations. When you've gotten that, the new pairs, you solve them as you normally do. You get your x and y, or you get two variables. You go back, put it in the third one, and you check. I know you'll be asking, Terry, this is a lot. Yeah, it's very easy. Let's pick an example now, all right? Let's pick an example. So let's say, for instance, we have a pair of equation here, and I want us to try. So we have 3x plus 2y minus z is equal to 19. We have 4x minus y plus 2z is equal to 4. And we have 2x plus 4y minus 5z is equal to 32. All right, so we have this now, and you are, for instance, given this and told to solve it. So what do you now do? Okay, so we're going to start with the first step. So the first step says that we need to arrange the three equations one on another. All right, so let's go quickly and do that. So we have the three equations. So let's start with step 1. Okay, step 1, the three equations one another. So be 3x plus 2y minus z is equal to 19. We have 4x minus y plus 2z is equal to 4. And we have 2x plus 4y minus 5z is equal to 32. This is equation 1, equation 2, and equation what? 3. Okay, so step 2 now said that take any pair of the equations and eliminate one of the variables by using step 2 and 3 in the 7 rules. So if you go back to the 7 rules of elimination, I told you in step 2 that you have to multiply it such that both either the x's will be the same or the y's will be the same. Do you remember? So I'm going to select equation 1 and 2 to make it easy for me. Is that right? To just follow it. So I'm going to select equation 1 and 2. So let me just write, let us use equation 1 and 2. Okay. So it does not really matter. Okay. You can use any of the equation. It does not really matter. You can use any of the equation to do it. So let's say we have going to have 3x plus 2y minus z, okay, is equal to 19. And we have 4x minus y plus 2z is equal to 4. Okay? So what I'm going to do, so remember I told you, so I'm going to multiply the coefficient of y. So I'm going to use y this time. I'm going to multiply it here to this whole equation. And the coefficient of x here, y here is 1 already. So it's going to technically remain the same, if you understand what I mean. So we're going to have, when you multiply that, so 1 is going to give us 3x plus 2y minus z is equal to 19. If you get this 2 and multiply, it's going to become 8x minus 2y plus 2z is equal to 8. So please, if you've not reviewed the previous video on elimination, the 7 rules, please, you have to go back and have a look again. So, and like I told you in that video, is that you have to do it in such a way that one of the variable must disappear. Do you remember? It said so that you have only 2 unknown. All right, so that means if we add this together, okay, 2y minus 2y, if you add it, they're going to give you 0. So it's going to give you 11x minus z minus so minus z minus 2z. Is that okay? So because what we're doing here is this. But if you notice, oh, I think I made a mistake here. I did not multiply. So this should be 2 times 2 should give me 4, not 2. I beg your pardon for that. So 4. So now if you add this together, 2y plus 2y is going to give you 0 minus z, okay, plus 4z, that will give you what? 3z. So that means this is going to become plus 3z is equal to, then 19 plus 8 will give you what? 27. So you can see that y, in this place, we made y to disappear. Okay? So the manipulation we did in this step 2 is that so that y should disappear. So we're now having 11x plus 3z. Now, step 3. Let's see what step 3, what do we have on step 3? So step 3, we'll go to the rules for step 3. Step 3, where we have that we have to now check. We have to select a new pair of equation for this. So we're going to check that. So let's go so I can read it out for you. It said take another pair of equation and repeat step 2 so that the same exact variable disappears. Okay. So in step 2, we selected 1 and 2. So we selected 1 and 2. So now I'm going to select 1 and 3. You can select any pair. It does not really matter. You will get the same thing. So let us use equation 1 and 3, right? We use equation 1 and we use equation 3. Is that right? So equation 1 was 3x plus 2y minus z is equal to 19. So we had 3x plus 2y minus z is equal to 19. Then equation 3, we had 2x plus 4y minus 5z is equal to 32. So we have 2x plus 4y minus 5z is equal to what? 32. Okay, so the same thing, you can decide to, there are 2 ways of doing this. You can decide to, this is 4 here, you multiply here by 4, and this is 2 here, you multiply here by what? 2. Or to make it less stressful for you, you can just decide to only multiply here by 2. You get the same thing, all right? So because of, to avoid loss of solving, so multiply here by 2, multiply here by 1. It does not matter, all right? So to avoid loss of solving, I'm going to use this. But you can also use 4 and 2, like we used in the previous video. You will get exactly the same thing. But you have to remember that the aim of what we are doing is that we want y to disappear. Because in step 2, we've manipulated y. In step 3, we have to manipulate y as well. So we're going to use this. So it's going to become 2 times this. It's going to give us 6x plus 4y minus 2z is equal to 38. Then we have 2x plus 4y minus 5z is equal to 32. Okay, so if you do the same thing with 4 and 2, like I told you, you will get the same thing. Just that I don't want to have big numbers to work with, but to give you the same thing. And like I told you in the 7 rules for elimination, that you either add or subtract so that this will disappear. All right, so we're going to subtract this so this can disappear. So if you subtract this, 6x minus 2x will give us 4x. 4y minus 4y will give us 0. Now we have minus 2z minus 5z. Can you see? Minus 2z minus 5z. Minus times minus will give us plus. So plus 5z. I'll give you minus 2z. So minus 2 plus 5 will give us what? 3z. So that means it's going to give us 4x plus 3z. And that will give us equal to 6. So these are the two. This is the new equation, and this is the new equation as well. Now let's go to the next step. So this is step 3. So let's go and check what we have for step 4. Now step 4 said now, oh, sorry for that. Step 4 now said now solve the new equation from step 2 and 3 as you would normally do. Is that okay? So now we have to solve the new equations. So the first equation we have is 11x plus 3x. Sorry, 11x plus 3z is equal to 27. So step 4 is 11x plus 3z is equal to 27. So step 4, let me use another color for that. Yep. So step 4, we have 11x plus 3z is equal to 27. Okay. That was what we had for step 4. Step 2, sorry. The new one is 4x plus 3z is equal to 6. 4x plus 3z is equal to 6. Okay. Now we're done with that. So I'm going to use the elimination method here, all right? So you can use both methods. You can either use elimination or substitution. But I'm going to use the elimination method because I think it will be easier for me here. So it's going to be, I'm going to subtract because these are the same. We don't need to multiply, all right? So 11 minus 4x is going to give us 7x. 3z minus 3z will give us 0. 27 minus 6 will give us what? 21. Divide both sides by what? 7. So therefore, x will be equal to what? 3. We've gotten the first value. Then when we're done with that, we've gotten x is equal to 3 for step 4. Then we'll have to substitute x equal to 3 into any of the equation, all right? So let me substitute it into this one. So we have 4x plus 3z is equal to 6. Then I have 4 into bracket 3 plus 3z is equal to 6. 4 times 3 will give me 12 plus 3z is equal to 6. Okay, so what I do, I'll take 12 to the other side. So we have 3z will be equal to 6 minus 12. Are you seeing that? So that with 3z will be equal to 6 minus 12 will give us minus 6. Then you divide both sides by 3. Okay, and that will give us z is going to be equal to minus what? 2. So that means using the elimination method, I found my x and I found my what? Z. Now let's go to step 5. So step 5 now said, substitute the two variables, which is my x and my z, to get the third what? Variable. Okay, to get the third variable. So in order to get this third variable, what I'm going to do now is that I'm going to use equation 1 because it says substitute the two variables, which is the x and z from step 4, into any of the original equation to get the third variable, right? So I'm going to use equation 1, like, because equation 1 looks easier, all right? So I will just, you can use any of the equation and you get the same thing. So step 5, okay? Step 5, okay? So from equation 1, so I'm going to select, okay? I'm going to select equation 1. You can select any of the equation and you get the same thing. So equation 1, what we had, but before we do that, we know our x is 3 and our z is minus 2. So we know our x is equal to 3 and our z is equal to -2. All right. So equation 1, what was equation 1 again? Can someone remind me? Yes, so it's 3x plus 2y minus z is equal to 19. So what we're going to do is the same thing. We're going to have it there 3x plus 2y minus z is equal to what? 19. Then x3 plus 2y minus -2 is equal to what? 19. So 3 times 3 will give me 9 plus 2y minus times minus will give me plus 2 will be equal to 19. All right. So we're solving for y. So you take all the other numbers to the other side. So it'll be 19. Take 9 to the other side, minus 9. Take 2 to the other side, minus 2. Then 2y will be equal to what? 8. Because 19 minus 9 will give you 10. 10 minus 2 will give you 8. Then divide both sides by 2. Therefore, my y will be equal to what? 4. So my x is equal to 3. My y is equal to 4. And my z is equal to minus what? 2. And that is that. So step 6, I told you that for step 6 is just to check if it's correct. So step 6 was check if you need to confirm in any of the original equations with the 3 variables. Okay, as usual, I'm going to use equation 1. So like I said, you can use any equation you want. So I'm going to select equation 1 again. You can select any equation. You should get the same thing. So equation 1 is 3x plus 2y minus z will be equal to 19. And our x was equal to 3. Our y was equal to 4. And our z was equal to -2. So when you put 3 plus 2, 4 minus z is -2, and you press your calculator will give you what? 19. And that is the answer for that. And with that, we bring us to the end for this solving simultaneous equation. So please, like I said, don't forget to like, subscribe. If you have any question, please let me know. You can drop it in the comment or you can send me an email directly and I will get back to you. All right. Have a nice day and I'll see you in the next video. Okay, see you soon.